Hi students, welcome to physics class. Today in this lecture we will discuss applications of Gauss theorem. The first application which we are going to discuss in this lecture, that is field due to an infinitely long straight uniformly charged wire. So we will find the electric field due to an infinite long straight wire, and that is uniformly charged, means the charge is equally distributed on the wire. So to find the electric field we will derive a relation for that, and to derive that relation we will consider a imaginary surface around this wire. So let us consider a imaginary surface around this wire, that is known as Gaussian surface. So here we have drawn here the Gaussian surface. There is a symmetrical surface around this wire, and the length of this surface, let it is L. And now we have to find the electric field at different surfaces of the Gaussian surface. So we will divide the Gaussian surface in three different parts. So let the first part is this one, first part, and the second part and third part here. So at the first part, third part will be here. So we have divided the Gaussian surface in three parts. In the first portion we will consider a small area element. We will have to find the electric flux at the first portion, then at the second portion, then at the third portion. So at every part we will consider a area element. Same here. And we know for a closed surface the direction of area element is always outward side. So we will draw the area element outward side. Similarly, for the third surface we will draw area element towards outward side. Okay, so let the area, this area element is ds. The area of this element is ds. Similarly, we have taken here the same size ds, and this one also the surface area is ds. So now we will apply the Gauss theorem to find the electric field. First of all, we will find the electric flux at three different surfaces, and we will add the electric flux of the three surfaces, and after that we will find the electric field by Gauss theorem. So let's start. According to the Gauss theorem, the electric flux E dot ds is equal to the Q by epsilon naught. Okay, so let us consider we are going to find the electric flux at these three different portions, and we want to find the electric field produced by this wire, this uniformly charged wire, at point P. That point is P. Here we want to find the electric field due to this wire. So we'll use the Gauss law here, and according to Gauss law this is our relation, and we know Q is the charge on this uniformly infinite long wire, and we know what is lambda here. Lambda is the linear charge density, and that is equal to Q by L. So from this relation we can write Q is equal to lambda L. So let Q is equal to lambda L by epsilon naught. This is our equation number 1. Now we will divide the electric flux in three parts, so we can write this phi, because this total flux is a combination of the first part flux, second and the third one. So we can write flux E dot ds is equal to the flux due to the first part, that is E dot ds. Similarly, the flux due to the second part, that is E dot ds. Second part is for this one. Similarly, we will write for third part, and what is our third part? E dot ds, and this is our third part. First one for this part, second and third one. So total net electric flux is the combination of this flux. So as we know, we have to find the dot product. So we can write EDS, that is electric field. So now we have to find the E dot ds product, and dot product is equal to EDS cos theta. So we need to find the angle between electric field and the area vector. Because the plus sign is there, so what will the direction of electric field? Electric field line is outward side, because we know for a uniformly charged wire electric field lines are always outward side. So electric field line direction will be like that in both sides. Okay, so now for the first portion, this is our first part, so we will solve for that. You can see here the area element n cap is this side and electric field E is this side. So what is the angle between them? The angle is 90 degree. So you can write here for this one, angle is 90 degree, and if angle is 90 degree, the cos 90 is equal to 0. So you can write EDS cos 90 for the first portion. Similarly for the second one, EDS, second part is also there. So n cap, this area vector is outward side and electric field is this side, so angle is 90 degree. So we can say here again the angle is 90 degree. So you can write EDS for the second cos 90. Okay, now for third part, what is third part? This one. So in this case, n cap, area vector and electric field both are in the same direction. So we can write E ds cos 0, because both are in the same direction, so angle will be 0, and we know cos 90 is 0, so these two terms will become equal to 0 and we will left with only this one. So we will solve for this one. We know cos 0 is 1, and this is our third portion, and this is your surface area. Now we have to integrate the surface area of a cylinder. So what is the formula for surface area of cylinder? Curved surface area of cylinder is equal to E into that ds will be 2 pi, r is the radius, let r is the radius of the cylinder and L is length, so that will be E into 2 pi RL. So electric flux is equal to, over a closed surface, is equal to E into 2 pi RL. So this is equation number 2. Now we have to compare equation 1 and 2. So from 1 and 2, from equation 1 and 2, you can write from 1 and 2, what is our first equation? That is from 1 and 2 both are equal, so lambda L by epsilon naught, lambda L by epsilon naught, you can write equal to this one, E into 2 pi RL, E into 2 pi RL. L will cancel, and from here we can find the value of E. So E will be lambda by 2 pi epsilon naught R. So this is the electric field produced by an infinite long uniformly straight charged wire, and you can see here the electric field depends on the R distance, inversely proportional to the R. So in the diagram we have to find the electric field at P point, which is at distance R from the center. So in that way we can find the electric field. Now if lambda is greater than, if surface charge density is greater than 0, so what will the direction of electric field for positive charge? Because lambda is greater than 0 when positive Q charge is there, and lambda is less than 0 means negative Q charge is there. So if positive Q is there means outward side, radially outward. So direction of electric field will be outward side, and if it is negative charge then it will be inward side. So this is the application of Gauss theorem in case of to find the electric field due to an infinitely long straight uniformly charged wire. In the next lecture, we will discuss the electric field at any point due to the charged spherical shell, inside the shell and outside the shell. So thank you class. Next time we will meet with the new application of Gauss theorem. Thanks.